Next example, a coin is tossed 3 times. A coin is tossed 3 times. What's the probability of getting only one head? I think we studied the sample space for tossing a coin 3 times in previous examples. Let's write again. Sample space can be head, head, head. All of them can be head, 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 tail, or head, tail, and head, tail, head, and head, and also head, tail. I'm sorry, head, tail, and tail, or tail, head, and tail, or tail, and tail, and head, and all of them can be also tail. So in here we have 8 different cases. All of them can be head, 2 of them can be head, 1 of them can be head, and all of them can be tail. The question asks us getting only one head. It means get which cases? These cases. Only one head, only one head, only one head. So number of, the event is in here, head, tail, tail, head, and tail, or tail, and head. So the probability for this event is number of event over number of sample space. So it's equal to number of event. How many elements are there in the set event? There are 3 over sample space 8. So what's the probability for this event is 3 over 8. Or we can also find it using combination. How? As we mentioned before, there are different possible cases for this one, for this experiment. What's that? All of them can be head. It means if we toss 3 times, 3 of them can be head, plus 2 of them can be head, combination of 2 from 3. 1 of them plus 1 of them can be head from 3. 1 of them can be head. The question asks us the probability of this case, plus none of them can be head. It means from 3, 0. So if we calculate them, this will be the number of sample space. It will be equal to 8. So number of sample space is equal to 8. But number of event asks us that one of them. It means from 3 different tossing, we get only one of them as head. So it can be combination of 3 from 1, which is equal to 3 factorial over 3 minus 1, 2 factorial times 1 factorial. 3 factorial is 3 times 2 factorial over 2 factorial times 1. We do not write again 1. 2 factorial, 2 factorial and 2 factorial cancel. So what's left? It's equal to 3. It means number of event is equal to 3. And if you divide the number of event by number of sample space, you will get the probability of this event, as we get it as 3 over 8. Next example, the integers 1 through 15 are written on separate cards. You are asked to pick a card at random, any of them. It means what's the probability that you pick prime number? So first of all, we should determine the sample space for this experiment. What's the sample space for this experiment? Sample space is all integers from 1 up to 15. It means number of sample spaces 15. And the event wants at what? The event wants from us the prime numbers. So let's write the prime numbers from 1 up to 15. What are the prime numbers from 1 up to 15? 2, 3, 5, 7, 11, and 13. So what's the number of event in here? 6. So let's find the probability for this event. Probability for this event is equal to number of events over number of sample spaces. So it's equal to 6 over number of sample space is 15. If we simplify them, we will get 2 over 5. So what's the probability for this event? 2 over 5 is the probability of picking a prime number from 1 up to 15. Since the number of outcomes in an event is always less than or equal to the number of outcomes in the sample space, so the probability for each event is between 0 and 1. Sometimes the possibility for an event is 0. So in this case, the number of event will be also 0. So 0 over number of sample space will become 0. But in some cases, number of event can be equal to number of sample space. So number of event divided by number of sample space will become 1. So in this case, probability for each event is between 0 and 1 inclusively. In this example, the problem says that a child is throwing darts at the board shown in this figure, as you see in here. The radii of the circles on the board are 3, 6, and 9 centimeters respectively. It means the smallest one's radius is 3 centimeters, and the middle one is 6 centimeters, and the large the radius of the large one is 9 centimeters. What's the probability that the child's dart lands in the red circle, given that it hits the board? In here we don't have any number of elements, but we can compare them by their areas. For example, the area of the total area of this circle and the area of this small circle or red circle. So let's find the total area. The total area will be the sample space. In here, sample space is equal to pi r square, as r is the largest circle's radius. So the area of the largest circle, I mean pi r square. Pi times r square is 9. 9 square is 81 pi in here for the largest circle. And even asks us the probability of hitting the red circle. So pi r square. In here, this r, the lowercase r, is the radius of the smallest circle, which is the red one. So it's 3 centimeters. So pi times 3 square, which is 9 pi. 9 pi. So the probability for this event is equal to number of event, or the area of the event, over number of the sample space is equal to 9 pi over 81 pi. If we divide them, pi cancelled by pi, and 9 with the 81, 1 over 9. So 1 over 9 is the probability for this event, or the probability of hitting the red circle. As we said that the probability of an event changes from 0 up to 1. Probability of an event is between 0 and 1. The probability of an event, which is 1, is called certain event. It means it will happen exactly, okay? But if the probability of an event is 0, it means it's an impossible event. There's no possibility to do or that event will be occur. For example, student rolls a dice. What's the probability of each following event? The first one, the number ruled is less than 8. Second case, the number ruled is 9. First of all, let's find the sample space. For finding the probability of an event, it's necessary to find what sample space. Sample space for this event, this experiment, is 1, 2, 3, 4, 5, and 6. It means rolling a dice has these 5 possible results or outcomes. For first case, A, for A case, the event number ruled is less than 8. Is less than 8, what are the numbers? 1, 2, 3, 4, 5, and 6. 7 is impossible because we don't have any 7 in a dice. So the number of even for this case is also 6. So what's the probability for A case? For A case, probability is number of event over number of sample space. And what's the number of event? The number of event, as you see, it's 6. So 6 over number of sample space is also 6. 6 over 6 is equal to 1. It means exactly that the number ruled is less than 8. All of these numbers are less than 8. It means all of the outcomes are less than 8. So the first event will exactly happen. But how about the second case? In second case, the number ruled is 9. 9 is impossible because, as we said, we don't have any number inside our sample space as 9. So in this case, for B case, event is an empty set. Why empty set? Because we don't have any number as 9 for ruling a dice. When we rule a dice, we will not get any number as 9. So again, the probability for the second case is number of event or over number of sample space. As an event is an empty set, so number of event will be 0 over number of sample space is 6. 0 over 6 is 0. So what's the probability for second case? When the dice is ruled, we will get 9. It's 0. It's impossible, it means. But for first case, as you see, all of these numbers, all of the outcomes are less than 6. So the probability is 1. It means it's a certain event, but the second case is an impossible event. Next example, a small child randomly presses all the switches in the circuits shown below. It means he can press the first one, second one, third one, first, second, first one and third one, or all of them. But randomly he press or she press the switch. What is the probability that the light bulb the bulb lights? In here, the question asks us for switching on the light. It means the light must be open. So the bulb must be open. I'm sorry. So in this case, there is only one way to make the light open. It means you should close all of these switches. It means the first one, second one, third one, all of them must be closed. But first of all, we should find the number of sample space. Let's find the number of sample space for this one. Number of sample space related to the switch or the circuits which are open or not. So if one of these circuits are open, so the light will be not open. If all of them are closed, so the light will be open or the bulb will light. So in this case, let's find the number of sample space. Number of sample space will be combination of if none of the switches are open from these three, plus if one of them is open from these three, plus if two of them are closed from these three, plus if all of them, three of them are closed from these three switches. So in this case, if we calculate them, we will get as 8. Some number of sample space will be 8. There are 8 different possible cases for these three switches. But the event want us what? If all of them are open. All of them are closed. It means this one. It means the composition of 3 from 3. From these three switches, all of them must be closed. So it's equal to 1. So what's the probability for this event? Probability for this event is equal to number of event over number of sample space, and it's equal to number of event is 1, as you see in here, and number of sample space is 8, so 1 over 8. So what's the probability that the light bulbs? It's 1 over 8. It means from 8 cases, one of them is possible that the lights are opened or on. In this example, the problem says that in a game, a player bets on a number from 2 to 12 and rules 2 dice. It means the sum of 2 dice can change from 2 up to 12, but the player bets on one of these sums. If the sum of the spots on the dice is the number he guessed, he wins the game. Which number would you advise the player to bet on? Why? Now look at here. These are the dice or the possible results or outcomes for first and second dices, and this is the order pairs which shows the possible results for each dice. For example, it can be 1 and 1. It means both dice can be 1 and 1. The first one can be 1 and the second one can be 2. The third one can, the other result is the first one can be 1 and the second one can be 3. 1 and 4, 1 and 5, 1 and 6, and so on. And the sum of them can be changed from 2 up to 12, as you see in here. 1 plus 1, 2. 1 plus 2, 3. 2 plus 1 is also 3. It means for 3 we have 2 different results. 1 plus 3 is 4. 2 plus 2 is 4. 3 plus 1 is 4. For 4 we have 3 different possible outcomes, as you see in here. 1 plus 4 is 5, 2 plus 3 is 5, 3 plus 2 is 5, 4 plus 1 is 5. So for 5 we have 4 different outcomes. And for 1 plus 5, 6, 2 plus 4, 6, 3 plus 3, 6, 4 plus 2, 6, 5 plus 1 is 6. For 6 we have 5 different possible results. For 7, 1 plus 6, 2 plus 5, 3 plus 4, 4 plus 3, 5 plus 2, and 6 plus 1. It means that the first one can be 6, second one can be 1, first one can be 5, second one can be 2, or first one can be 2, second one can be 5, and so on. But the sum of them is 7, and we have 6 possible results for 7. And for 8 we have again 5, for 9 we have 4, for 10 we have 3, for 11 we have 2, for 12 we have only one choice, which is one result or one possibility, which is 6 plus 6. Both of the dice must be 6 and 6. So as you see in here, the most possibility is for 7. The sum 7. It means that the sum of or the number which obtained from these two dice is 7. So the most possibility is for 7. So it will be better that player must bet by 7 number, or the number 7. Why? Because the most possibility or probability is for 7. What's the probability for 7? As you see, the total number of sample space is 36. From here, from this figure, as you see in here, we have 36 different possibility or probability for this experiment. But for 7, the number 7, I mean, we have 6 different probability. So what's the probability for 7, number 7, I mean? The probability for number 7, or for probability for this event, which get number 7, is equal to number of events over number of sample space, which is equal to 6 over 36, and it's equal to 1 over 6. So what's the probability for number 7? It's 1 over 6, and it's the highest probability for this event, for this experiment. So we advise him that this player must bet for which number? For 7 number, because the highest probability for this experiment the number 7 has. Check yourself. One is your homework about this subject. If you have any question about this, check yourself, or the problems in this, check yourself, so you can contact us from school WhatsApp number. We will respond you. Thank you for your attention.